The solar system is a place of profound beauty and immense scale. Out in the distant reaches, nearly 1 billion miles from the sun, Saturn reigns, a gas giant wrapped in golden bands and encircled by shimmering rings. But among Saturn's many moons, one stands out: Enceladus. At just over 300 miles across, Enceladus is tiny, yet its surface gleams with a brilliant, icy white, making it one of the most reflective objects in the solar system. For years it was dismissed as just another frozen, silent world. But science thrives on surprises. Beneath its pristine shell, Enceladus hides a secret. It's alive with geological activity. Its south pole is scarred by tiger stripes, fresh fractures venting material from the moon's interior. These plumes are evidence of a powerful energy source deep within. Enceladus shattered our assumptions about where life might exist. Despite surface temperatures plunging to -200 degrees Celsius, something extraordinary is happening below. Saturn's gravity needs Enceladus, generating enough heat to maintain a vast global ocean beneath miles of ice. A hidden ocean, locked away in darkness, far from the sun. This tiny moon, once overlooked, is now one of the most intriguing places in the search for life beyond Earth. The story of Enceladus is just beginning. Our understanding of Enceladus changed forever with the arrival of the Cassini spacecraft. In 2005, Cassini's flyby revealed something astonishing: plumes of water vapor and ice erupting from the moon's south pole. These geysers, blasting hundreds of miles into space, proved Enceladus was geologically active. Cassini's instruments detected a faint atmosphere and traced its source to the tiger stripes, vents connected to a subsurface ocean. The material ejected by Enceladus even forms Saturn's E-ring. With liquid water, heat, and organic molecules, Enceladus became a prime target in the search for life. Cassini's data revealed a global ocean, kept warm by tidal heating, sandwiched between rock and ice. At the ocean's floor, hydrothermal vents may provide the energy and nutrients needed for life, just as they do on Earth. Cassini didn't just find water, it found a potentially habitable environment. The question was no longer if Enceladus could support life, but if it already does. The search intensified. Water is essential, but life needs more, a cosmic recipe of ingredients. Cassini's daring flybys sampled the plumes, analyzing their composition. The results were extraordinary: water vapor, nitrogen, oxygen, methane, carbon dioxide, and other simple organics. These are the building blocks of life, as we know it. The presence of molecular hydrogen was especially exciting. On Earth, microbes use it for energy at deep-sea vents. Enceladus's ocean isn't just water. It's a chemically rich environment, a primordial soup. But one key ingredient was missing: phosphorus, vital for DNA, RNA, and cellular energy. Cassini's instruments couldn't confirm its presence, leaving a crucial gap. Was Enceladus's ocean truly missing this element, or had we simply not detected it yet? The search for phosphorus became a central mystery. Still, the evidence for habitability was mounting. Enceladus had water, energy, and most of the essential elements for life. The moon's potential as a cradle for biology was undeniable. The next step: probe deeper into its secrets. The stakes had never been higher. Analyzing Enceladus's plumes was a race against time. Cassini's instruments had only milliseconds to capture and analyze ice grains as the spacecraft sped through the geysers. The Cosmic Dust Analyzer, or CDA, was up to the task, but interpreting its data was challenging. Many grains had drifted in space, altered by radiation and collisions, making it hard to know what truly came from the ocean below. Scientists needed fresher samples, ice grains that had just erupted from the moon's interior. Hints of complex organic molecules appeared in the data, but ambiguity remained. To solve the puzzle, Cassini would have to dive deeper into the densest part of the plumes. It was a risky maneuver, but the potential payoff was enormous. Only by sampling the freshest material could scientists hope to unlock Enceladus's secrets. The stage was set for a daring final act. The world waited for answers. In 2015, Cassini made its boldest move, diving just 30 miles above Enceladus's south pole, straight through the heart of the plumes. This close encounter captured pristine ice grains, unaltered by space. The data was clearer and richer than ever before. Scientists discovered large, complex organic molecules, 10 times heavier than methane, similar to the building blocks of proteins. The evidence was unambiguous. Enceladus's ocean contains the complex chemistry needed for life's precursors. This discovery, announced in 2018, was Cassini's final spectacular gift. While not proof of life, it showed Enceladus is one of the most promising places to search for it. The daring dive had paid off. The mystery deepened, and the world took notice. The confirmation of complex organics elevated Enceladus from habitable to prebiotically fascinating. These molecules are the raw materials for life, potential cousins to amino acids that form proteins on Earth. The parallels with Earth's deep-sea hydrothermal vents are striking. There, life thrives in darkness, fueled by chemical energy from the planet's interior. Cassini detected tiny silica grains in the plumes, evidence of hot hydrothermal activity at the ocean floor. Enceladus has water, energy, and complex chemistry, a complete system for life. The only missing ingredient was phosphorus, but recent reanalysis found strong evidence for phosphates in the ice grains. If confirmed, Enceladus would have all the ingredients for life as we know it. It's a natural laboratory for studying how life might begin. The experiment may already be underway, hidden beneath the ice. Cassini transformed Enceladus into a top target for future exploration. Its instruments found the ingredients but not life itself. To answer the ultimate question, we must return with new missions, equipped to search for biosignatures. Concepts like the Enceladus Orbolander aim to orbit, analyze, and even land near the tiger stripes, sampling fresh plume material. These missions will hunt for chemical fingerprints of life, such as specific amino acid patterns or cell-like structures. The goal, not just to ask if Enceladus could support life, but to find out if it does. Unlike Mars, Enceladus offers a living, accessible ocean to explore today. The answer to, "Are we alone?" may be locked beneath its ice. Only by returning can we hope to find out. The journey continues.